Hello. Um, I'll be talking about the catastrophe modeling, which is an area of actuarial sciences. First of all, what does an actuary actually do? Actuaries are basically mathematicians. Their course at university involves mathematics, and as an actuary, they use multiple formulas, as you can see up on the screen right now. So there's mortality equations. What's the chance of someone dying? Or for example, we have expectancy of life. There are a lot. On an everyday basis, actuaries can work with a variety of issues. For example, earthquakes, hurricanes, to cancer rates, cancer risk, insurance. And in my opinion, it's a great job for people who are keen and able at maths. As for how you become an actuary, in Britain we have the Institute and Faculties of Actuaries, and in order to become, I think, a partner, you need to pass 18 different exams. However, there are some universities that will give you exemptions for about 6. So you only have to do 12 exams, which is still quite a lot, but it makes a big difference. Now, catastrophe modeling is a very specific part of being an actuary. It involves, well, finding out the exposure the insurance company is exposed to, and it uses computers and computer programs to estimate how much an insurance company would actually lose in the event of a tornado or a hurricane or any catastrophic event. So, yeah. Well, actuaries have many different ways of modeling a catastrophe. However, there are 4 main principles. There's the event, the hazard, the vulnerability, and the financials. So the event, well, it just takes into account the different catastrophic events and calculates how much damage they can do, and they take that data from past catastrophes, geography, geology, all of that. The hazard just evaluates how dangerous a certain area is overall. The vulnerability, it just estimates the damage done to different properties or buildings from a hazard, and it takes into account building codes, how tough they are, architecture even. And the financial module is just estimating the cost of repairing damages that are caused by the events, and who would be responsible for covering those costs. So here is a formula, right? Okay, to calculate insurance premiums based on the potential losses. Okay, so we have here that P equals to blah 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 blah. LC plus LN is the expected losses. K is the risk transfer cost, and F is the fixed overhead expenses. So, for example, admin fees, underwriting fees, all of that. C plus T plus mu, that represents, I guess, the variable expenses, the expenses that can change, right? But P is just the base premium, so you need to add a couple things on to make it the final premium, because the base premium only takes into account a couple variables. But as an insurance broker, obviously you want to make as much money as you can, so you should probably add on extra money, extra fees, say. So to calculate the final premium, you should multiply the base premium, which is P, by a factor for territory, the amount of insurance itself, the construction type, the building codes. So if the building codes are pretty good, then there should be a discount. You should put a mitigation discount, amount of insurance factor, and a deductible, plus your policy fees, which will give you the final premium, which is probably the most ideal way for an insurance company to make enough money. An exceedance probability curve, also known as an EP curve, describes the probability that various levels of loss will be exceeded. They tend to go from top to bottom because obviously the cheaper losses happen more often, right? And those that are like a tornado that are very infrequent happen, well, not as often as a door breaking. If you integrate the area underneath a EP curve, so between 0 and the x-axis, and then it touches 0 on the y-axis, then you would find a number called the AAL, which is the average annual loss, which is what insurance brokers take into account when they underwrite a building, for example. Let's have a look at an example here. An underwriter has received 2 new proposals for business. However, he can only write 1 account. So he needs to find a very holistic way of taking the AAL and the coefficient of variation so that he can examine both the risk and exposure and the volatility of this insurance product. So what he should do is probably take X% of AAL, combine that with Y% of the variation coefficient to find what's called a technical price. The technical price is, as I said, a very holistic way of looking at insurance and how much exposure, financial exposure, a building is exposed to. And so in general, it's, as the technical price is actually lower, the financial risk an undertaker is exposed to is lower, which is better for the insurance company, because if, for example, Hurricane Katrina version 2 hit, then the insurance company will not be out of pocket. The coefficient of variation is calculated by the standard deviation over the AAL. So it's mainly to determine how volatile the insurance could be. And in this case, if you would do some very simple mathematics, you find out that the technical price for account B is much lower, and hence it's better, and the underwriter should take account B because it's much safer. As with many concepts, there are advantages and limitations to this idea of using catastrophe models. Well, firstly, they are modern and constantly updated, so that means that it doesn't rely solely on historical data. For example, in 1988, 200 people died of an earthquake in a building. That wouldn't be accurate in this current day and age because, well, building quality has obviously improved. The building codes are much stricter, and I guess the model is more accurate because it just represents a scenario that could happen just like right now and not 40 years ago. In addition, there are multiple formulas that actuaries can actually use, and so they can back up their data by applying their numbers and their factors to different models, and if they're around the same, then their findings are pretty accurate. Okay? But yeah, thank you for listening. Any questions?